Model, context, protocol. What exactly is it and why is everyone talking about it? This is a crisp, no nonsense, no BS, hands-on introduction to model context protocol for the absolute beginners. So no prior knowledge required. We'll cover everything from the absolute basics. We'll understand why MCPs are needed in the first place, what are MCPs, we'll look at the MCP architecture, then we'll learn how to use an existing MCP server, we'll then build an MCP server and an MCP client from scratch. And you'll also gain access to a hands-on lab environment exercises and resources that you can use to follow along this video with me. Now we'll begin by looking at why do we need MCPs in the first place. Let's start with something we already know, ChatGPT. The way it works is, when you send a message to GPT, which is the LLM, it responds back with its response in the form of a generated text or other forms like image or audio or video. But let's say we were building a flight GPT app, and I say I would like to fly to North London. It should book a flight for me. Well, LLMs can only respond back with a generated text or other supported formats. It can't perform any action on its own. But what does taking an action mean here? By the way, we discussed this in more detail in our previous video about the introduction to AI agents and MCPs. So do check it out if you just want an overview of what MCPs are. However, I'll take a minute to summarize that here anyway. Now, in our application, when I say I would like to fly to North London, my application should be able to interact with these third-party flight services, such as whatever is listed here, and then retrieve flight details from these sites, and then also compare that against my preferences, such as whether I prefer cheap or luxury flights, or my seat preferences or meal preferences, and based on all of that information, make a decision for me, and not stop until it's retrieved enough information to be able to make a decision and then book the flights for me and tell me the flight details. So I'd like my AI to take action for me. So we need something magical that can do that for us. And what is that? Well, those are called AI agents. And AI agents are able to interact with third-party platforms or websites, gather information, and combine that with a memory that it has based on our previous conversations, and then interact with an LLM, which is the real AI here, to make a decision for me. And that magical thing is known as the AI agent. An AI agent can interact with third-party tools, have its own memory, and interact with an LLM and go back and forth until it has completed the task that it is assigned to do. Now, in the previous video, when I shared this, someone asked in the comments, yeah, so AI agent is a magical thing, but what exactly is it? So let's spend a minute on AI agents here. But note that we have an entire video coming up on understanding AI agents in depth on our channel next week. So do subscribe to be notified when the video is out. And by the way, if you have any questions on this one, please drop it in the comments below so I can answer them in my next video. So all build workflows in the past, well, long-running automation scripts, for example, the good old VMware vRealize orchestrator, if you're from a VMware world, or the Microsoft System Center orchestrator, if you're from the Microsoft world, or modern tools like Zapier, or just good old-fashioned series of Python scripts just duct taped together. And you had all of these complex logics in place to make decisions and go into loops and connect with third-party tools. Now, if you did all of that, then you already know how an AI agent works. Except, in case of an AI agent, the agent relies on AI in the form of LLMs to make these decisions. The agent often interacts with AI to know what route to take as part of a conditional decision, or how many times to iterate in a loop, or what third-party tools to interact with, or how to process the user input, or know when the script's goal is achieved so that it can exit. So yeah, an AI agent is just like your old automation script, except now it can think. So how does that apply to our use case here? A typical AI agent workflow looks like this. The user sends a request to the AI agent. The AI agent interacts with the LLM to extract the right details from the user's input, as different users might input details differently. In this case, the AI agent asks, here is the user's input. What does the user mean? The LLM responds back saying that the destination is London. The AI agent then requests the LLM for assistance in identifying which third-party tools to interact with. There may be other third parties as well, such as hotels or rental cars or other databases. The LLM helps the AI agent identify that the flights are the third parties to interact with. The AI agent then interacts with the airlines and retrieves flight details. The AI agent then asks the LLM what to do next, and the LLM says fetch the preferences from the database. So the AI agent fetches the preferences from the database. These details are then sent to the LLM, requesting it to make a decision. The LLM identifies the right flight to book and sends back the information to the AI agent. The AI agent then books the flight and sends the flight details to the user. As you can see, at various stages, the LLM interacts with the AI agent to process data and make a decision. So here is a super simplified version of an AI agent that's written in Python without using any framework or anything complex. It interacts with the user to get inputs. It then calls LLM to retrieve the specific details from the user's input, such as origin, destination, and date of travel. It then fetches flight details from third-party websites. It then fetches user preferences from memory or database, and then sends these details to the LLM to make a decision, and finally books the flight by making a call to the third-party site. Now that's a super simplified version of the workflow. It's missing many additional LLM calls that the AI agent would make, the decision-making loops that the AI agent would go through if the right match is not available the first time, but that's for another time. We have frameworks like LangChain and LangGraph that can help make this workflow better. We'll discuss that in detail in the upcoming videos. Note that all code that's shown in this video are pseudocode only, so do not try to run it as is. Refer to the actual code in the labs associated with this video. So coming back to this, we said that an agent can interact with third-party platforms this way. But how does an agent really interact with the third-party platform? It does that through what are known as tools. A tool allows the agent to interact with another platform. Let's take a closer look at that. So here the agent has the ability to interact with these airlines using a tool for each one. But how does a tool interact with an airline? Going back to our pseudocode, if you look inside the fetch flight details function, you'll see a tool call for each airline. And we pass in the query parameters to it, such as the origin, destination, date, etc. And we make a tool call for each airline and append the results and return that. Now, if you take a closer look at that call, you'll see that each call is different. The first one is API/flights. The second one is flights list. The third is list flights. Also, their responses are different too. Each airline has its own standard when it comes to their APIs. There are hundreds of airline sites and there are millions of other third-party sites. And if I want my application to interact with all of them, do I need to write all of these code? Now, we are in the AI world and I shouldn't have to do this. So gone are those days when I would sit and write programs to connect to these different flight service providers myself. So why can't AI just do that for me? And only if there was some magical solution that existed. And so comes MCPs, or Model Context Protocols. Think of MCPs as a guide for the AIs to choose the right APIs and interact with the third-party platforms. MCPs provide agents the context they need to interact with third-party platforms. What does that mean? Let's dive deeper into MCPs and how agents can discover and use MCPs. MCPs follow a client-server architecture. Now, agents use the MCP client to interact with a server. So usually, MCP clients are embedded within coding agents in IDEs like Cursor, Windsurf, KodeKloud, or Cloud Desktop. We could then get these agents to connect to a local database instance like MongoDB or browser tools. For example, here's a use case where we ask the AI agent about a recent problem with the UI of our application. The AI agent goes into a quest of going through the Git history, checking backend and frontend code, and finally identifying the commit that caused the change. This does not use an MCP server though. While developing front-end web applications using the browser, MCP Server provides the AI agent access to the browser console logs and HTML elements that can be used to troubleshoot front-end issues. And finally, a really cool use case is in data engineering. By providing MCP Server read-only access to our data, using the Stripe, BigQuery, and Data Studio MCP servers, we could now ask specific questions about missing data and transactions, and the AI agent can now dig in and identify root cause of such issues by combining information from these different sources. So who builds the MCP servers? If I was the owner of a business or an application and I want AI agents to interact with my app, I would build and maintain my own MCP servers. You'll see a lot of vendors announcing the launch of MCP servers for their services. If you go to the Model Context Protocol repository on GitHub, you'll see a list of official integrations. MCP servers can be built by anyone really, as long as they know how the APIs work. So for companies that have not built official MCP servers, there are community members who have built their own versions. Of course, these need to be used at your own risk, as there is no guarantee that they are tested or up to date with latest versions of the vendor's APIs. But what does it mean when I say anyone can build an MCP server? How is that possible? For that, we need to understand what MCPs are and what the Model Context Protocol specification is. So up next, we'll discuss what is MCP, what the MCP architecture is, and then proceed to using an MCP server and building our own MCP servers and clients. But before we proceed with the next step, let's head over to the lab and get familiarized with the lab environment. We're now going to access the lab environment that's provided along with this video. Use the link in the description below to create a free account to access the labs. Start with the first lab. This is the interface to our lab environment. On the left, you have a set of instructions. In this case, there are 7 tasks for you to complete in this lab. And on the right, you have a VS Code server. You can access the terminal by clicking anywhere below and going to terminal. So this is access to an actual system hosted on our labs. Now, in this lab, we're going to get started with RuCode AI Assistant. So RuCode AI Assistant can be thought of as a cursor or Windsurf alternative, which is a VS Code extension. So if you click on the kangaroo button here, you're going to be able to see a chat interface. Let's continue with the lab and configure this environment. All right, so here it says open a new terminal in VS Code on the right. So we've opened a new terminal and run this command to look into bash profile. So if you look into your bash profile, you're going to be able to see a set of keys that you can use during this lab session. Here we're going to need the OpenAI base and the OpenAI key. So we're going to keep a note of this for now. Let's continue to the next step. Okay, so the goal here is to configure RuCode with these API keys. So we're going to go into the API provider and select OpenAI compatible, and then the base URL. The base URL can be found here. So we're going to select this and paste it right here. And the API key. The API key is going to be the OpenAI API key. So we're going to copy this and paste it here. The model is going to be what's given here. So it's a DeepSeek free model. So we're going to put that in and click OK. Now we're going to go and click Let's Go. What this does is it sets up RuCode. Now we're just going to copy this prompt and paste to make sure that it's working. And we can see that it's now starting to respond to us. This means that the API key setup is successful and RuCode is working. Let's click on OK to continue. And you can now explore asking these questions to RuCode. I'll let you explore those by yourselves. So head over to the labs and explore these by yourselves. And once you're done, come back and continue with this video. We'll now understand what MCPs are and what are its different components in a super simplified manner, and then we'll see how it can be used. Now, let's look at what an MCP server really is. MCP itself stands for Model Context Protocol. Model refers to the AI itself, the LLMs, the large language models. The context refers to giving AI or the model context of a third party. And protocol simply means a set of standards. So MCP itself is just a set of standards that define how AI applications can work with each other. If you go to modelcontextprotocol.io and look under specification, you'll see what it means. It defines a set of rules that needs to be followed by someone building an MCP server or a client, such as the communication between the server and client must use a JSON-RPC format, the connection must be stateful, the MCP server must offer any of the following features, such as resources, prompts, and tools to the clients, and the clients must offer sampling routes and elicitation features to the servers. Now, don't worry if you don't know any of these details yet. We'll discuss these in more details in a bit. For now, simply understand that anyone can build an MCP server as long as they adhere to these standards defined. And if a server is built following these standards, any client can use it. Now we'll understand what MCPs are and what are its different components in a super simplified manner, and then we'll see how it can be used. Let us now look at MCP architecture. If I had to truly understand what an MCP server is and how to build it, I would first assume a state where no MCP servers exist. Then I would know the why behind building the MCP server. So for a minute, let's assume that MCPs don't exist and I'm building a client to interact with the server. Now, what would I need? First, I would need to know what the server can do. Like, what APIs do the server support? What capabilities it has. For this, I would usually refer to the API documentation of that server and figure out everything that the server supports. Now, these are known as tools in the MCP world. The server must list all of its capabilities as a list of tools defined in a specific format. Each tool should have a description of what it does and an input and output schema. Next, we may need certain data such as refund policies or guides to cities or FAQs, and these details may be needed to be passed through to the AI to support its decision making. For example, if the user has a preference to book only flight providers that support a refund, then the information in these guides come in handy. Now, these are known as resources. The MCP specification has a clearly defined structure to define resources. The resources should have a URI that points to the resource, a name, title, and a description that defines what this resource does. The URI could be HTTPS that points to a resource on the web, or a file that's located on the file system, or a location of a Git repository. Okay, so we now have tools and resources defined in our MCP server. Now, using these tools, the client or the AI agent that uses the client needs to call the LLM. Now, you can leave it up to the AI agent or the developer building the AI agent to create the right prompt for the LLM. So whoever is building the AI agent might decide to send a prompt to the AI agent, say, find me a flight to London. However, as a developer of the MCP server, you know the better prompt is that you are a travel assistant, and when the user asks about flights, you must call the search flights tool with the origin, destination, and date, and format all dates as the particular format that's given here, and be helpful and concise. So as you can see here, there are specific instructions given along with a specific format of dates, and these are known as prompts, and that's the third type of entity that an MCP server can expose. So MCP specification defines a specific format to define a list of prompts. For example, in this case, we have a list of prompts that defines a name for each prompt, a title, a description, and a set of arguments that can be passed. So those are the high-level details that an MCP server needs to expose to its clients. Let us now see how to build an MCP server. There are SDKs available that make this easier. So we'll understand what MCPs are and what are its different components in a super simplified manner, and then we'll see how it can be used. So how does the server and client communicate with each other? It uses a JSON-RPC protocol. But what exactly is JSON-RPC? So the JSON in JSON-RPC stands for JSON, which we already know. And the RPC stands for Remote Procedure Call. And together, JSON-RPC defines how a client can call a procedure or a method remotely and pass parameters and receive a response. Now, what that basically means is, say there is a server that has a method, such as add in it. A client should be able to invoke that method remotely and pass parameters to it. So the protocol defines clear guidelines on how data is sent and received. The client, when making a request, should send a JSON document that contains the JSON-RPC version, which must be set to 2.0, a method to call on the server side, and a list of parameters to be passed through to the message, along with an ID number, which is a number. The server then sends a response back that has JSON-RPC version specified, which is 2.0, along with the result and ID, and an optional error field with the error details if there is an error. Now note that JSON-RPC is a simple protocol meant to be kept simple. As such, it is stateless and does not define how data is transmitted between client and server. So that's up to us to decide. It could be HTTP, WebSockets, TCP, UDP, Unix sockets, message queues, standard I/O, etc. So MCP supports HTTP and standard I/O as the transport mechanisms for client-to-server communication. Now here's an example of an implementation of JSON-RPC in Python with the client and server. So the server uses the JSON-RPC SDK for Python to define a simple add method, And the client uses the JSON-RPC client SDK to send a request to the server and receive a response. And this example uses an HTTP transport. Next, we'll see how to use an existing MCP server. Let's first look at how to use an existing MCP server, and then we'll learn how to build our own. Kind of like learning how to drive a car first before learning how to engineer and build one. So how is MCP meant to work? Now, in the past, you wrote code for interacting with an API server directly. But now with MCP Server, you're no longer concerned about APIs. Instead, you make a call to MCP Server, and the MCP Server handles interacting with the endpoint. Your tool can query the MCP Server to know its capabilities and then make a tool call. Now, where is this MCP Server hosted? Now, it can be hosted locally on your machine or remotely hosted by the vendor themselves. Now, if it's hosted locally on a machine, this is where you run a local instance of MCP Server and connect to it via standard I/O or HTTP. Or there are remotely hosted MCP servers, either by your organization to have a single MCP server accessible internally across the organization, or say by a vendor themselves to allow AI agents to interact with them. In that case, you connect to it via HTTP. Let's first look at how to configure an MCP server locally. If you're configuring your IDE like Cursor or Windsurf or tools like KodeKloud to MCP Server, they come with an MCP configuration file, such as the mcp.json file for Cursor. It is a JSON file that has a high-level object called MCP servers, and that contains a list of MCP servers under it. In this case, we have the flight MCP. Provide the command and arguments to start the MCP server. Environment variables can be passed through if necessary. And when this is configured, these IDEs start an instance of the MCP server in the standard I/O mode. Standard I/O is the simplest and fastest way for two local processes like Cursor or Claude and your MCP server to talk to each other without needing HTTP or sockets. So it's lightweight, isolated, and great for testing dev environments like this. Once connected, MCP server, the agent lists the tools available, and then you can chat with it to interact with the MCP server. But let's say you decide to run your own instance of the server, maybe to be shared by multiple IDEs locally. Then you may run your server first and then configure the MCP client to connect to it via HTTP by providing a URL like this. In this case, the MCP client connects to the MCP server via HTTP. And what happens when the MCP server is hosted remotely by the vendor? Now you can change the URL to point to the remote MCP server. Now, when you do that, though, you want to make sure you take care of authentication, authorization, data privacy, and trustworthiness of that server. Because now you're sending your data to an external server that's managed by a third party, so that's important to keep in mind. Now, continuing on, if you'd like to connect your own AI agent or app that you're building, then you would use the Python SDK and build the interaction with the MCP server into your app. Now, here's a pseudocode. We'll look into this client code in a bit more detail in a few minutes, but these are the different ways to connect to an existing MCP server. So let's head over to the lab and practice using an MCP server. In this lab, we'll explore how to use and connect to an MCP server that already exists. So let's begin. First, we have a multiple choice question. So what are the transport modes supported in MCP? In this case, there are a few options: WebSocket and REST, HTTP and standard I/O, and we know that the answer to this is HTTP and standard I/O. So I'm just going to select that and go forward. The next question is, what files are present in the flight booking server directory? These questions are there to help you explore and understand the code base as it exists today. So if you go here, you can see that there is a flight booking server directory already available, and there are some files in it. So this is the server that's already exists. The answer to this is the third one is server.py and pyproject.toml. That's the correct answer. So the first step is to explore the flight booking server. So we have found the flight booking server directory. Now let's explore what's inside the server.py file. So if you go here and if you select server.py file, you can see the code in the file. Now don't worry about understanding this code for now, because we're going to look at this in a few minutes. For now, you just have to take a quick look at the code. So coming back to this, we're just going to proceed. Next step is to use RuCode. So RuCode is the chat extension that's available here, and this is already set up for you. So I'm just going to click on OK and proceed. All right, so we're now going to test if RuCode is working properly. So I'm just going to copy this prompt and paste it here and run it, and we'll just see if it responds. All right, as you can see that it's responding to my request. So I'm just going to continue. All right, so in this step, the goal is to connect to the MCP server. So we're going to go into RuCode plugin and then go up to MCP servers at the top. And here you get to see edit project MCP. I'm just going to click on that. And we can now copy and paste this MCP configuration file here. So as you can see, the command is uv and the arguments are run python server.py. And what this does is it runs the command uv run python server.py. So it's basically just going to run that Python server file. Now I'll come here and I'll refresh the MCP servers. And as you can see, the MCP server is detected here. You can see that the status is green. And if you expand this, you'll get to see the tools and resources that are available inside this MCP server. All right, so now we're going to activate and test it. So I'm going to click on done. And I have a prompt here that I can copy and paste. So what we're trying to do here is we're asking RuCode to search for flights from LAX to JFK using the flight booking server. So it's now going to detect the flight booking MCP server. And it's now going to ask me for approval. So I'm just going to click on approve. And as you can see, it's completed the task. This means that the MCP server is working as expected. And click on OK. So there are a few more questions. I'll let you go through this and figure that out by yourself. We'll now see how to build an MCP server. So far, we've learned that MCP servers have three components: resources, tools, and prompts. Now, what would these be for our situation in our use case? So our MCP server must have resources such as list of airports and their details, flight statuses, sea maps, weather in the target locations, booking information, gate information, policies, and loyalty programs. These can be referred to when making decisions or taking actions. The tools are the actions we'd like the MCP server to perform, such as search for flights, get flight details, create and edit bookings, check in, select seats, add baggage, etc. And finally, we must define a set of prompts for finding the best flight, optimizing budget, handling disruption, etc. Once we are clear what we want to build, we can proceed to building the MCP server. The Model Context Protocol site has some handy SDKs along with the specification. These can be used to simplify the development of the MCP servers. The SDKs can be found at modelcontextprotocol.io website under the SDK section. And let's start with a simple Python SDK. So the overall approach is to import the fast MCP library and initialize an MCP server from it. We'll then define tools, resources, and prompts, which we will see in a minute. And finally, run the server and specify a transport protocol, either standard IO or HTTP. In this case, it's set to standard IO, and we can change to HTTP if required. Next, we define resources. So resources, as we discussed, are defined as normal functions. In this case, we define a get airport info function that returns airport codes. And we add a decorator at the top called mcp.resource, and then that's what makes it a resource. We can then define other similar resources the same way. Next, we define tools. Tools are also functions that accept certain parameters from clients, using which we search our internal database and return results. Adding a MCP tool decorator makes it an MCP tool. Next, we define prompts. Prompts are predefined prompts that can help the AI select the best flight based on conditions. This is best defined by the developers of the MCP server, as they know best what is right way to prompt. This is also a function, and at the top of the function, we add a decorator called mcp.prompt. Now that we have coded the server, how do we run it? When creating the fast MCP server, there are different options, such as creating a stateful server, which is the default behavior, or a stateless server by passing the stateless HTTP flag to true. And finally, while running the server, you may set transport to standard IO for standard IO or HTTP and specify a host and port. Or to be more specific, you may specify streamable HTTP that can stream the output. Well, let's head over to the lab and practice building an MCP server. Next, we'll see how to use the MCP inspector. So before building a client to then test with the server, we could simply use the MCP inspector to test the server that we have built. To start an MCP inspector, run the npx command with the model context protocol / inspector language. This starts a web server. Then go to the URL that's given in the output of the command. The MCP inspector is a web interface that looks like this. Here, you provide the URL to the MCP server, and then you can start listing prompts, tools, and resources using the navigation bar on the right. In this lab, we're going to explore developing an MCP server. So the lab starts with a number of multiple choice questions that helps you test your knowledge of the concepts you've learned so far. So this question, for example, asks what are the 3 main features exposed by an MCP server? Is it HTTP standard I/O WebSocket? This we know are the transport protocols, resources, tools, and prompts, client server transport. We know that the answer to this is resources, tools, and prompts. So let's select that. And there are a few other multiple choice questions that I will let you go through and answer by yourself. So I'm just going to skip those through for now. The first hands-on task is to set up the Python project for the flight booking server. The instructions are given here. So the first thing we need to do is open a terminal. So I'm just going to open a terminal here. And make sure we are in the CD home lab directory. And the goal is to initialize the Python project using the uv init flight booking server command. So I'm just going to run that. And as you can see, the project has been initialized. And you can see the directory here. So there is a main.py, and then there is a readme file, which is just a template. So we're now going to cd into the flight booking server directory, and we're going to add the MCP CLI using the uv add MCP command. What this does is it installs everything that's needed for us to build the MCP server. Now we're going to check our work. As you can see, all the tasks have been completed. Let's go to the next step. Now you'll see a server.py file staged here. So here you can see the first version of our server.py file. So we've already coded a little bit of it. For example, here you can see a function called getAirports. This is imported from the mcp.server.fastMCP, and the MCP server is initialized here. So the task here is to open the server.py file in a project directory, find the getAirports function, and add the correct MCP resource decorator above it. Here you can see the information that's needed to be put in while configuring the MCP resource. So here we're going to add, using the @mcp.resource, and within the brackets, we're going to specify the resource type and name as file and airports. Now we can go and check our work. Right, so that was successful. So the next question asks to configure the MCP tool decorator the same way. So if you go here, you can see that there are 2 additional functions added to the file. You have the search flights and create booking function. And for this, you must add the MCP tool decorator. So I'm going to let you do that yourself. And if you find, if you run into any difficulty, you can always go to the solutions tab here and find the solution to the task. We're going to skip this for now. The next one is creating prompts. As you can see, there are 2 functions added again. These are the prompts, and you're supposed to add prompts there. We now have the MCP server developed, but we haven't configured it to work with the RuCode agent. For this to happen, you must follow the instructions given here. So once you have opened the RuCode agent, you must click on the MCP servers at the top. So this is basically the icon that's given here. So click on that, and here you have edit global MCP and edit project level MCP. So in this case, we want to edit the project MCP. So click on that. And this opens up the local mcp.json file. Now we must copy the mcp.json file that's given here. And if you look into this, here, this is the name of the MCP server. So it's called flight booking. And then here you have the command and arguments and the current working directory. So this working directory is the same directory as the one that you see here. And This command is the command that is used to run the Python project. So it's basically uv run python server.py, which runs this server.py file. And that's basically it. So if you go back to the file, to the root code here, click on project MCP, make sure it's saved, and then go here and click on refresh MCP servers. And this is how you confirm that it's working. So you can see that it's now listed the flight booking project, and you can also see a green circle here, which indicates that it's working. And inside, and if you look inside, you'll be able to see the tools as well as the resources that are available. So you can see the file, airports file that's listed here. All right, so next we can simply click on done. And now here is a test prompt that's available that you can paste in to see if, as you can see, root code wants to use a tool on the flight booking MCP server. So it's asking our permission to use the MCP tool. So we're going to approve it. It's now come back with the task. So it's identified 2 flights from LAX to JFK and their flight information. So this confirms that our MCP server is being used by root code. I will now let you explore the other prompts and play around with the MCP server. I'll see you back on the video. Let us now look at how to build an MCP client. As discussed earlier, a lot of agents support MCP clients automatically. So IDE tools like Cursor and KodeKloud have a mcp.json configuration file that simply needs to be configured to point to the MCP servers. However, if you'd like to build your own AI agent, in that case, you might want to build the client from scratch. So we now have this sample server created with tools, resources, and prompts. This is a super simple version of the server. The next step is to build a client. So here's a super simple example of a client. So we use the same fast MCP client library. We first connect to the server running on port 80 on the HTTP protocol, and we then list its available tools using the list tools command. We then call a specific tool such as the search flights tool and pass origin and destination, and we can read a particular resource using the read resource method and get prompts using the get prompts method. Now let's understand a little bit more detail about the client. So we had learned that on the server side we have features like resources, tools, and prompts. Similarly, on the client side we have a few features as well, such as routes, sampling, and elicitation. It's important to understand what these are before we proceed. But before that, we're going to look at something more important, and that's called the context. So contexts allow the server to talk back to the client, maybe for giving updates or sharing progress, etc. So let's say the client initiates a booking process that may be a long-running task. The server might want to send periodic updates to the client before the actual response is shared. So for this, we use the context. So import context on your server, then use the methods like info. You can send information, level messages to the client, and you may call report progress to report progress updates to the client. And you could use the debug message to send debug messages to the client. So we'll see a few more examples of these in the upcoming slide. So now that we know what contexts are, let's start with the client level features such as routes. So what are routes? Think of routes as folders on the client machine that the MCP server is allowed to see or interact with. They are like shared folders, so you expose to the server from your local file system. But why do you want to provide access to file system to the server? Some MCP tools like code linters, compilers, file readers need access to real files, your project folders, but for security, the server shouldn't have access to your entire machine. So the client says, here are the safe folders or routes I'm willing to expose to the server. For this, on the client side, we define allowed routes and include that while creating client session. And on the server side, we use the context.session.listRoutes method to get the list of routes allowed. Next is sampling. Now, at times, the server might want to interact with the LLM for specific reasons. For example, the server might want to send some resources to the LLM to summarize it. In such case, the server does not interact with the LLM directly. Why? Because the server may be used by different clients, and we want the client to have control over the model selection, token limits, etc. The server is purely the logic and tool definitions. The client takes charge of LLM interactions, and different clients might choose to do that differently. The server should be just a lightweight and decoupled from the entire AI infrastructure. So how is that done? On the client side, we need to define a sampling handler function and pass that in while creating the client object. On the server side, we can now send a message to the client using the context.session.createMessage method and pass the sampling message, and then return the response back to the server. Next is elicitation. At times, the server may want to interact with the end user to get more information to make a decision. For example, while making a decision to pick the best flight, the server may need additional confirmation from the user to make sure the user is happy with the choice made. In that case, the server can send a message to the client to elicit a response from the end user. To implement this on the server side, we call the method context.elicit with a message to the client. The client must have an elicitation callback handler defined, and this is the handler that is responsible for fetching a response from the user. And while creating the client session, you must specify that elicitation callback handler. Well, let's head over to the lab and practice working with building an MCP client. Well, that's all for this video. In the next video, we'll discuss AI agents in action, and we'll build our own custom AI agent using LangGraph. So do subscribe to this channel to get notified when the new video is out.